welcome back, guys. So here we are on part 2 of day 2 of Advent of Code. We're going to keep iterating on where we were last time. We did some testing and we made some changes, but let's take a look here and just kind of see what's going on. So the elf finished helping with their tent and sneaks back over to you. Anyway, the second column says how the round needs to end. X means you need to lose. Y means you need to end the round in a draw, and Z means you need to win. Good luck. The total score is still calculated in the same way, but now you need to figure out what shape to choose so the round ends as indicated. The example now goes like this. In the first round, your scorer will choose your opponent will choose rock, and you need the round to end in a draw. So you also choose rock. This gives you a score of 1 plus 3 plus equals 4. In the second round, your opponent will choose paper, and you choose rock, so you lose with a score of 1 plus 0 equal 1. In the third round, you will defeat your opponent. It's scissors with rock for a score of 1 plus 6 equals 7. Now that you're correctly decrypting the ultra top secret strategy guide, you would get a total score of 12. Instructions for the second column. Okay, great. So now, similarly, we're not just simply calculating a score, but we're taking it as an instruction to figure out which way to go. So we know that rock, paper, scissors. So we can look at it like this, that if we're on scissors, which is a 2, if they're on scissors, which is a 2, and we need to beat them, then we go to rock. So if we're on 2, we go to rock. And we'll beat them. If we need to lose, we go plus 1 more of that. So essentially, this is like a module sort of operator, maybe I said that too quickly, but we can use math to kind of figure this out, right? We don't have to do anything like super complex. So we know that if they've called rock and we need to win, we can simply just call paper plus 1, and it essentially is your win is plus 1 wrap after 2. If we need to draw, then we just call the same numeric value like we did previously. So we know that no matter what it is, if it's a draw, we really don't have to do anything. I suppose we should know we don't really need the mappings anymore for the second XYZ, but we just need to know numerically where to go. So if it's a draw, we're going to have the same numeric value. So we can pretty much hammer this out pretty quickly. So let's take a look at our tests. So we created this function. We're going to create a new function, and we're going to leave what we have. We're going to leave total score. And what's kind of interesting is I'm going to change total score because I want to be able to inject a function that receives a string, and we're going to call it score, which is a function that receives a string and returns an int. Okay, so then what we can do is when we call total score, this has to go like that, point. So that any function, it can be named whatever it wants, we can pass into total score. So this is the first augment we're going to do, because total score is going to be important here. And then we can pass score in. Yeah, okay. So we can pass that into our original function, and then we can go back to our tests, and then we know, so then we can actually do this. But what's interesting here is that we could actually augment this method if we wanted to, but I think that would get a little confusing. So I'm not going to do that. Instead, I'm going to grab this, and we're going to create just a test score forced. We'll just call it forced. and we'll create a function called func score forced. A string, it's probably a terrible name, but it'll get the job done. And so what we can do now is we can go back to our main test. And actually, I'm going to leave this one alone. We're gonna use the same kind of pattern here. We'll delete all the excessive testing that I did to make sure it was working. But this one is interesting because I'm actually going to put a score func here, and I'm just going to define it as a func of s string int. So really, actually, you don't need to do the variable here, and I'm going to probably move that in the other place too. But that way we can then we can just say score func is score, which is what we've been using, and then we can use test.score func here. And so then as we kind of augment this total scoring, we can get a where's that at? Oh, return 0. Okay, so that's done. Let's total score. Yeah, let me get rid of this. Just I don't know why I left that in there. Okay, score forced. So now we'll go back to our test, score forced. This is score forced. And so now we can iterate on this. So let's take our test data again. So A and Y should end in a 4. So A, Y should end in a 4. Okay, good. Let's say B and X should be a 1. B, X, 1. And then third round, you'll defeat your opponent's scissor with rock. This is the same inputs on the previous test. What was the third one? So I guess X, Y, Z means defeat or to win. So think of what it's A and Z or something. Is that right? So in the third round, you defeat your opponent's scissors with rock. Okay, so they called C. Let's take this for instance. So these are our expected outputs. If we run score forced, we know that we're not going to get that. But let's do some maths. So we know that we need to split the lines, and we'll do a little bit of this just like we did before. A little bit of repeat code. We really care about player 1's score. We don't really care about player 2's anymore. But I think the underlying scoring remains the same. So that's kind of interesting. I guess I could augment this further, but that's okay. So we know that. And so if item 0 equals, let's say X, we'll go with the X case first. So we know that if it's an X, at the first round, your opponent will choose A and draw X. The second round, your opponent will choose paper and you choose rock, so you lose. So if it's an X, we need to intentionally like ditch the game, right? So that essentially means that wherever our opponent is, if they're at rock, we need to be 2. Because if we're at paper, we need to be rock. If they're at scissors, we need to be paper. So that means we need to be P1 plus 2. So, okay, so P2 equals to P1 plus 2. If P1 is greater than 2, P1 minus equal minus 2. that means our score has to be so we know that if we're at 3, so we're greater than 2, so if we're at 3, we're going to go back to 1. That's basically what we're saying. So we're going to go all up to 2, and we're going to go back to 1. Really, we could just do it like this. So done. If items sub 1 equals to x. Okay. So that's the rest of the score. If item sub 1 equal to y, okay, if we're equal y, it's a draw. Okay, so if it's y, then P2 equals to P1. Done. And if it's Z, so if we're gonna win. So it means if they choose rock, we need to choose paper. So if they're at rock, we need a +1. So this is pretty much we can get rid of this, and we can just say, look, if we're this, I'm going to do an else here. I'm not like super excited about that, but I think it just kind of nails the point home, right? So let's see what we got. CZ, test score forced, expected 1, actual 7. All right, let's look at our rules real quick. I'm reading them. The third round, you will defeat your opponent's scissor with rock for a score of 1 plus 6. So let's see here. Player 2 is a scissor, and we know that we need to beat them, so we're going to go from a 2. I had the wrong value here. The expectation should be 7, because if they are a scissors, we are trying to lose, or trying to win rather, with the Z. So we need a rock, which puts us at 1 plus 6, which is 7. And so now I've got my test, and that's running. And so what we can do, going back to this is the same, I think, textual input as this ABBX CZ. So we can actually take this test here we have for total score, and we're going to just call score forced because we want the other function. This just kind of gives us that dependency injection type pattern, but it'll work here really well. And then we know that the score is no longer 15, but our expected score will be 12 in this new test. So we're going to go ahead and put 12 here, and we're going to run this, and that should pass. Okay, perfect. So we've now got 2 separate tests for the full input, and we got a pretty good idea of what's going on there. So the last thing we're going to do here is we've got a new set of input. I think it might be the same. I don't have time to compare. Actually, we can compare real quick here. If I just grab, oh, well, there is no new input. It just says what will your total score be if the exact same input. So we'll come back here. We'll delete this because that was a waste of my time. And we'll go here. And now we know we've got a score, which we're already doing today. And then we can just call score forced. And we'll pass in the score forced function here. And so when we run this, bring this up here for a second. Do I have some logs in here? I think I have some logs. Yeah, I don't need these in here anymore. I figured out my stupid mistake earlier where I thought I was debugging something that was broken, and I wasn't. Let's run this again, just so we can get it nice and plain. So our original score is here. That hasn't changed, and since we're injecting this new function, we can get our score here. Go back to advent of code, plop that in the box, hit submit, and we are still wrong. We are wrong for some reason, and that I don't know. So let's go back to day 2 and let's see if we can figure out what's going on here. So let's just check the rules. The first round, your opponent will choose rock A and Y. So you also choose rock. This gives you a score of 1 plus 3 for drawing, which is a 4. Okay. That's in our test here. Let's look at our tests. So that's in our test here. 4. Okay. So I think these are generally right. So there's got to be a situation where we're not. Here's where the problem comes into play. We're not necessarily getting the same result, right? So we know that we have values 1, 2, and 3, and if we're greater than 3, greater than 3, we need to reset that to a 1. But is that always true? So let's look at this. If we're at 3 and we want to go plus 2, we'll actually be at 2, right? So I think that's where our problem is here, without going through a whole bunch. So let's do this then. Let's create a test scenario where this is B, but what if the answer was C, right? So C and X. So an X means what? That's we are going to intentionally lose. Your opponent chooses paper and you choose rock, so you lose. So we want to lose. So if they are choosing C, which is scissors, we want to choose paper. So paper is a 2. So our expected output should be a 2 because it should be the value that we're choosing plus a 0 for winning. So what happens when I run this test? I'm going to guess this fails. Yeah. So in actual set, yeah, so that's way off. So I think the problem is just, I already kind of saw it, but I wanted to create a test to verify it. It's this right here. We really should be doing P2. Let's see. So if we're 4 and we minus 3, we're at 1. And if we're at 5, we're at 3. And if we're at 3, I don't think we'd ever be in that situation where we were at 3. So if we're 6, that wouldn't happen because we would also be 3. So I think this is the answer here, is that we just need to take whatever P2 has become by adding values and then just subtracting 3 from it. And let's see if our test is right. Okay, so our test passes now with our new value. I'm pretty confident that's what our issue is. So I'm not really going to go through a whole bunch of other iterations. I'm just going to simply run this again, get our new value, and we're going to retry. And, I didn't pay attention to see if it was higher or lower. Look at that. Okay. So that's kind of an idea of, taking a test-driven development approach to advent of code. I'm a pretty big advocate for test-driven development when it comes to new development, when it comes to testable scenarios like this. And I do quite a bit of test-driven development in my day-to-day development life. Typically, I introduce the tests midway through development or to a new feature. But I certainly end with tests so that we can have some sort of repeatable contract to known sets of inputs and known sets of outputs. I think advent of code is a great place to test your TDD because you get a known set of input and a known set of output. Is this the fastest way? Absolutely not. There are way faster ways to code, and if you were going to do advent of code for speed, I wouldn't necessarily recommend this approach. But if you're just doing it for fun and for building your skill sets and taking a methodical approach on things, I think it is a great idea to take a language. In this case, I'm using Golang, but take a language of your choice and build some sort of TDD environment so that you can test and repeat and test and repeat. And as you can see here, you saw where, based on the initial set of tests, I made some assumptions that passed, and my test was working, particularly early on when I thought that a tie just meant number plus number, a player one plus player two position. And that worked for the test case they gave. But in actuality, if you look at the rules, it was player two position plus a hard-coded 3. So that landed me with a score that was off. And that was because I didn't fully. I should read a little bit more instead of jumping to conclusions. So I'm going to end here for this part, and we're going to start up. We'll probably do a couple more of these Advent of Codes in preparation for Advent of Code this year. But I sort of have a plan kind of brewing in place where I want to create. We'll talk about that in future videos, but I want to create some sort of like ecosystem where I can call an AOC utility and automatically scaffold out the project with some functions and some test case, like a pre-boilerplate table-driven tests. But we'll dive into that a little bit more in the future. Well, anyway, I thank you for your time. I'm out. You have a good day. I'll see you next time.